once again, and we're going to do another installment of what it is to make the metal Antikythera, which is going to be a long thing, but we'll get through it. Later on today we're going to record a little bit about how to use the Antikythera, and we'll talk about that in another episode that'll be probably put in a little bit different place in the blog. Alright, so now on to business. I've got the CAD program open, and we're going to go look at the gears in front. I have a Saturn 57T, a Jupiter 76T, and a little bearing that goes on the front and makes it where the octagonal shaft becomes round so it can turn in the front plate. And this is the bearing right here. We're going to grab him and we're going to make him in a new file, and we're going to come over here and paste him into our shiny new file. Oop, wrong one. Let's go back over here and grab him again. Control C, into no name we go, Control V, and there he is. There's our bearing. And to get the center on him for milling purposes, we're going to draw a line to get the center of this, because I'm going to need a little screw hole to tack him down to the bed. Draw a circle, and I'll go right there at the middle, and I'll say 1.5 millimeters, and that will give us a 3 millimeter circle. In one of my other videos I said something crazy and gave him a 1.5 and said we had a 1.5 millimeter circle, but the circle is actually 3 millimeters. As you can see over here, the diameter right here is 3 millimeters. So anyways, now we pretty much got that done. We're going to save it to our new file. File, save as, and I want to do it here in planetary gears, and I want to say front panel front bearing. And we're going to save it as a drawing, and then we're going to come back and do another save as, take the dot drawing off of it, and then we'll come down here and save it as the ASCII2 DFX file, or DXF file, and that is the file that our other software can understand. Alrighty, now we're going to go ahead and close that, and we'll go back and we'll grab our Saturn, and do the same thing. Five. We'll delete our line, and we'll come back here and we'll save it, file, save as Saturn 57T drawing, and we'll just cancel because it's already done, but that's how I did that. And we did the same thing for Jupiter. Now our files are ready to be processed by our G-code software. So we'll go ahead and close this thing here down. Nope. And nope, don't save any changes to that. And we're going to close this. And that. And we're going to go and grab our DFX to G code. And here we have DFX to G code. And we're going to go File, Open, Antikythera Metal, and Mill, and the front panel gear file. And we're going to grab our front bearing DXF. We're going to open that. And there's our little front bearing. And the first thing I'm going to do is I'm going to go and take and move my workplace 0. I'm going to choose auto, and there he is, much bigger and nicer. And then we're going to find out which order our shapes are in. And that would not be the first thing I want to cut, so we're going to move him down. And shape 2 is the first thing I want to cut, so we're going to move him up. And basically, the only thing I'm interested in doing right now, the first step of the way, is to cut this hole. Of course, we could cut the outside first. That would save, that's more trouble than it's worth. So what we're going to do is we're going to take and we're going to cut the inside hole. And I'm going to choose to cut him with bit number 3, which is a 2 millimeter end mill, and I'm going to select this, and I'm going to tell him just to drill the bore. And he knows that the end mill is not quite as big as the hole is. That's fine. It's just the right size for me to put a screw in to hold him down. And so now I'm going to disable these other 2 shapes, and I'm going to export the G code for the first step, and front bearing, and I'm going to call this 1 STP. Front bearing 1 step, and I'm going to save it. And all 1 step's going to do is just drill that hole. Now I'm going to turn on my other shapes. That'll be the second shape that we do, because once we drill our hole, I'm going to put a screw in it, and then we're going to cut this shape out right here. And I want to cut this on the inside, but I don't want to cut it with a 2 millimeter end mill. I want to come down here and get my 1 millimeter end mill that actually looks like it's 1.25, but that's because of the flex and the way the machine interprets it. So we're going to come in here and we're going to say cutter compensation, and I'm going to choose right compensation, and you'll see the new line is on the inside of the other line because the end mill is kerf. The end mill center is going to follow this line. It's going to create a kerf that's twice as wide, and that'll make the inside of this the correct size. Sounds crazy, but that's the way it is. And so now we're going to export this, optimize and export, and we're going to say front bearing 2 STP, and we're going to save that. And now we're going to go back and we're going to enable shape 2. Nope, don't want him. I want him. And we're going to disable shape 0, and we're going to cut our outside shape, and we're going to cut him with tool 2 as well. Well, actually no, I don't have to. We can come back here and use our blistering fast tool 3, and we're going to come back, and when we use tool 3 we want a little bit bigger infeed depth than that, so we're going to go 1, 2, and our bigger fatter end mill can go much faster, so we're going to go 400, and then we're going to come back over here and we're going to select our cutter compensation, and we're going to cut to the left, which is on the outside, and you'll see the circle just got bigger because he's going to pass quite a ways outside because we're using a 2 millimeter end mill instead of a 1. And so now I'm going to go export, optimize shapes and export, and this will be step 3. This will be 3 STP, and we'll save this G code. Come on, mouse. Save, and there we go. Now we've got that G code. Now I'm going to go back, and because I didn't set my draft and stuff for the first one, I'm going to disable him, and we're going to go back to this first one again real quick, and we're going to go still on tool 3, and see we got a real low infeed on here, so we're going to go 0.12, and we're going to change him to 400, not 4,000, and that way we'll drill just a little faster. I'm going to redo this one step, save, and we're going to replace the file. Alrighty, so now we've prepared our G-code files, and so I'm going to go ahead and end this for right this moment, and we'll get ready to run the machine. Alrighty, hello everybody, this is James. I'm in the S&T Geotronics shop, and we're getting ready to start our machine running. You can see the machine view on the screen, and we're going to open up the software that controls our machine, which is called Universal G-Code Sender, and we're going to open that program up and connect our machine. It's a Gerbil. Yep. Connect the machine. Let's tell him what port he's on. Oh, we're not plugged in. So we'll plug in our machine, and then we'll TTY on USB 0, and we'll connect the machine. That works better when the machine's actually plugged into the computer. And he always wakes up in an alarm, so we're going to unlock him, and then we're going to tell our machine to home. And you can see in the machine view the Z-axis is starting to raise up. He's going to go test his limit switches, and he'll go home. And I'm going to take the liberty of going and grabbing us a nice file that we're going to work on. Open. Antikythera metal front panel gears. Oh dear. Well, there we are, right there. In mill. Saved it not where I thought. We'll grab our front bearing step 1. Open, which is just a simple hole. And we're going to go over to our machine, and I'm going to change his bit real quick, because we have a little tiny end mill, and we're going to go ahead and get a little bit bigger end mill, because we want our 2 millimeter end mill to drill this hole. Sorry, this is off camera. I suppose I can move him over where he is. in the camera. Step size XY. There, that's better. We'll move our bit over into the camera view. Just like that. And then we'll grab something to pop our bit out, because it sticks a little bit in the collet. Point. There he goes. And then we'll extract this bit, which is little bitty, tiny, little bitty 1 millimeter end mill. And we're going to put him back in the container. I call him Lucky. I haven't actually broken that one yet. I've done quite a bit with him, but now we're going to grab this nice fat 2 millimeter end mill, which was really tiny in the scheme of things, but compared to the one, it's 4 times bigger. And then I'll put my collet nut back on. With a little luck. This motor is super easy to turn, so I'm actually going to have to hold him to get the collet nut started, which ends up being a 2.5-handed thing. And I missed. The chips out of there. One day I'll get a collet motor that has a lock on it and a removable there he goes. Yay. Now I've got my bit loosely in there. I'm gonna go Y plus a little bit. Too much. And I'm going to go Z. I want to bring my Z down 20. And I'm going to enter that number. I'm going to go Z minus 20. You can see the Z going down. This is for the purpose of, I'm going to set the 0 for this end mill. At minus 20, I want him to be just touching the material. And now I'm going to go ahead and tighten him up. And he'll actually go up a tiny bit as I tighten him down, as the collet jams him up into the motor just a little bit. So now I'm going to start my spindle motor running, and I'm going to bump it down just a little bit at a time. Until he touches. So now I'm going to go all the way down to 0.04. There we're at 0.04. Now I'm going to Z minus until he touches. There he is. That was 6 Z minuses. So that puts us at a pretty good place. We're at minus 1.12. I'm going to call that a good enough 0. So I'm going to 0 my Z right there. And now I'm going to pick him up a bit so he doesn't touch anything along the way. I'm going to bring him up 5 millimeters off of the work so I can move him around without worrying about running into something. And then I'm going to come back and I'm going to bring this all the way over. Let's see how far over I can get. Actually, no, we're going to take him right here in front. I'm going to take this part right here in front where everybody can see it good. I'm going to grab him out of the metal right here in the front. Let's make sure we got enough room to go all the way over and get it. Looking like we do. Oh yeah, there's plenty of material there. I want to move him back over here. Looks like a good spot. So now I'm going to 0 my other 2 axes. And then I'm going to go to the toolbox and I'm going to tell them to return to 0. He's going to drop that bit down for me right there. And now our 0 is set. And I got my G code in there. I'm going to go ahead and play the G code. And you'll see our machine will take off and drill that hole for us. Here he goes. Time to turn on the vacuum. It's going to get noisy for a minute. And there you have it. The machine is drilling the center hole out for us so that we can put our hold down screw in. It shouldn't take too terribly long. And I'll see you back when it finishes this. Alrighty, this is James back in the S&T Geotronics shop, and our machine is finishing up this hole that we sent him out to drill. Just has a couple, 2 or 3 more passes to go, and he'll be done, and we'll put the screw in and start the next job after we change the bit. He's definitely through the metal, so I'm going to go ahead and stop him. And I'm going to go to the toolbox and return him to 0. Shut off the vacuum, which makes it a lot easier to hear. And I'm going to shut down the spindle and then we'll change the tool. I'll move him forward, and then we'll put the small end mill back in. The good thing about this machine is that despite all the other shortcomings it has, it does a pretty good job of remembering where it's at. So now we'll take this and then we'll knock this out like that. And then I will swap the end mill back for my Lucky end mill if I can find him. Where is Lucky? There's Lucky. And I'll put my big 2mm end mill back in the tray and get out the Lucky 1mm end mill. He's lucky because I ain't broke him yet, but it's gonna happen pretty soon. It'll happen. Hopefully I made the G code right and we don't break him on camera. That's always embarrassing to break something on camera. I need to redesign my vacuum chute where I can remove it and install it quickly and easily. So I can get this collet on and off more easily. It would be easier if this motor didn't turn so easily. And there we go, we're on. I'm going to run it up like that, finger tight, and then I'm going to move my Y out. Pull my tool down, maybe if I'm lucky, so it touches the material. And then we'll tighten our collet back up. Put our tools up. And then we'll start our motor running. And then I'm going to bump Z down till he touches. Here we are. 1, 2, 3, 4. 4 passes up. I'm going to set it to 0. And then I'm going to toolbox, return to 0. He's going to return to the job 0. And now I'm going to get my next file that I want to run. Oh wait, I forgot the most important part. I forgot the most important part, everybody. We got to put a screw in. Grab my screwdriver up here. Go to my box of stuff. Mark gave me a neat little box to keep my accessories in, but it's a little small to get my fat old fingers in. So here's my screw, and there's my screw hole that I created, and then we're going to drive us a screw in that hole just like that, and that'll hold this centerpiece from flying away when we cut it. And that's the whole point of this, is to have that little screw right there. Put the screwdriver away, and then we'll tell them to return to 0. We'll get our step 2. Second step, G-code, open. And there's our second step, designed for our tiny little end mill. Once he gets to 0 and stops, we'll hit play. And off he goes. It'll take him a couple trips around before he actually touches the metal by design, because I don't want to run into a high spot and break my tool. So I always start just a fuzz bit above where I'm actually going to be, and the screw actually held him down a little bit lower. The metal on the bed tends to bow up in the middle as you cut it. Anyways, he'll make a couple of trips around. We're not going very fast or very deep, so this is going to be a slow process because our end mill's getting old, and we're just going to take it easy. I probably could have gone 150 on this instead of 100. So he's basically moving the tool around at 100 millimeters a second, which sounds really slow, and it is really slow, but that is a teeny tiny end mill. And we have end mills that are even smaller. Have end mills all the way down to 0.4. There they are, little tiny end mills. That's like 0.3 or so millimeters. Really tiny. Have to go really slow and really shallow. But you can do really detailed work with it, beyond what we're going to do here. And we should be getting ready to contact the metal in just a moment. At which point I'll have to start the vacuum, otherwise we have a big mess. I should have zeroed the Z-axis once I put the screw in. But it'll be okay. It's just going to cost us a couple of trips around. On second thought, I'm going to stop him. I'm going to zero this there. I'm going to return him to 0. Now I'm going to replay it. We're going to start where we left off. We want to make sure that there's plenty of depth to go all the way through. So I'm going to restart the job. But he's going to start the process at minus 0.2. instead of where he was at. So we're just going to make fewer trips around before we contact. Sometimes I mess up like that. After all, I'm just now getting used to running the machine. And it sounds like he's starting to touch. Just a little bit. Next pass. Still don't see anything, but you will in a moment. There he goes. Now I have to turn on the vacuum. As you can see, the machine is going slow and careful, and it's going to be a while. So I'll be back when he's a little closer to done. Alrighty, our machine is about a third of the way through, and lots of noise going on. I've got the 3D printer over yonder making the hold down for it. I guess I should have showed you the process of making the little hold down piece, but we'll do that on another one. So the machine's going, and in another little bit he'll get through and we'll go on. For right now, this is just showing the machine going. And going he is. Alrighty, we're about 2 millimeters of the way through our 3mm material. The screen shows us being halfway because we're actually able to machine to 4mm deep, but we'll probably stop him off once he just gets through the metal. Anyways, this is just to show the progress of what's going on. The machine's running smoothly and cutting, and slow but steady. Here we go. Alrighty, it's hard to see, but the machine is actually probably just about through the metal, and it's just starting to take a little bit of the waste board. I don't want to go too deep into my waste board, but we'll go a couple passes, and then we'll stop the machine off, and then we'll put the hold down in. While it was cutting, I went over to the other machine and designed a hold down for it so we can hold it down while we cut the outside. So it's going to require the removal of the screw, the removal of the center, the installation of this hold down piece, and then we'll do a tool change, and we'll cut the outside of this. So I'm going to go ahead and stop off my machine. After he does one more round, let's let him go to 3.404. And when he comes back around after this, we'll stop him off. And you can see over here on the screen that he's gone way down through the circles. And but he doesn't need to do these bottom layers because, like I say, he'll just be cutting into the waste board. And here we go. We've gone down one layer. I'm going to go ahead and stop him. And I'm going to return him to 0. I'm going to shut down the vacuum, which quiets it down in here a bit. I'm going to shut down the spindle. And then we're going to jog our controller. And move our tool off of the bed. And we're going to come back in here and pick our Z up where we can get our tool out. There we go. And now we're going to swap tools again to put our 2mm device back in. Here goes our collet. And we'll knock our collet out. Grab him, and then we'll get our 2mm tool and put Lucky the 1mm guy back up. This one particular little end mill has cut a lot of stuff. Doesn't do it very fast. I broke quite a few before I got my formula down. Low and slow. Blow the chippies out and try and get this thing back on. One day I'll design me a better nozzle. Then we'll move our Z back down. Let's go Y plus to get him where he'll touch, and Z minus. He'll go down the whole 20mm, and then we'll put him on the bed. Actually, I'm going to bring him up one. One plus. Because every time we change the tool, we end up going down a little bit. Because I put the tool on the bed. And then I snug it up. And that actually brings it up off the bed a tiny bit. And then I bring him back down. There we go. Now we'll start our spindle motor back. And I'm going to bump the Z down, tiny tinies. Get us a good spot to zero from. I'm going to 0 the Z, and then I'm going to tell them to return to 0, and we'll go get our new file. Oh, I'm doing it again. This can't, well, we'll go ahead and get the file. 3-step, open, and then we'll take and jog our controller. And we'll grab our screwdriver, shut our spindle motor off, and we'll grab this piece out. Right here. Normally we make a round to it, but today we have an octagonal to it. There it is, it cut all the way around. We could have gone one more pass, but that'll be just fine. And now we're going to get our hold down. It's going to hold this down for us. Hopefully it fits. It should be really snug. Yep, it is really snug in there, but it's in there. And now we'll add 2 screws to it. And that'll hold our bearing in while we cut them out. Get another screw out of the box. Have them nice and tight. We'll return to 0. Boy, that's going to be very close to our plastic. And we'll start our motor, our spindle motor. Fan's already going, and we'll start this a-going. Play. And here he goes. He should go round and round, just outside of our plastic. Probably the next round we'll start touching, so we'll turn on the vacuum. This will go pretty quick because we're going 4 times as fast and quite a bit deeper on each pass. And there he goes. With the bigger end mill, I can take quite a bit more metal at a time. The small end mill takes tiny chips, and the tiny chips clog up the flutes of the end mill, so you have to go very slow and take little tiny bites so that the end mill can clear itself. Anyways, this shouldn't take nearly as long, but you might get dizzy if you I left you keep watching him go round and round, so I'll pause this recording for a bit and then we'll come back when he's a little further into it. Wow, here we are. We're almost halfway done. It's really going through this fast. Of course, we're going 400 millimeters a second and we're dropping 0.12 millimeters per revolution. We could probably get away with taking even bigger bites with this end mill, but I like to conserve my tools because they're expensive, and in this recent political environment they're getting harder to get. Be back in a couple of minutes when it's just about done. Alrighty, he's all the way through. That didn't take but a couple of minutes. I might have could have let you watch the whole thing, but you'd be dizzy from watching him go round and round. At least I am. Anyway, so now we're going to stop him and collect our piece. I'm going to let him have one more round, and then we'll get the piece out. There we go. We're starting our round, and around he goes. And there we are. Let's return him to 0. Shut down our vacuum. Stop our spindle. And then we'll send him out here where we can get him. And now we'll grab our piece. Take our 2 screws out of our hold down, which worked pretty good. We're going to use this same hold down a couple more times. And there's our inside bearing. Get the hold down out of it. And there it is. There's our front bearing, ready to go into a machine. And we'll get the parts and see if he actually fits on the shaft he's got to go on. Oh, neat. Here's our bag of metal parts that we've made so far. Here's the brass piece. This one's made of brass. It was done by Lost Wax Casting, but it's the same as the plastic one, and we'll see that our bearing fits on him just about right. Probably a little more snug on the plastic version. I don't know that the plastic version's in our bag. Plastic version of everything else is. Let me grab a plastic one and we'll compare. Put our ring gear back in. Later on we're going to machine an aluminum one. So here's a good old plastic one right here. This is the same part 3D printed. And we'll find that our 3D printed one is ever so slightly bigger than our cast one. And he fits on there nice and snug. Ready to go. That there is exactly what we wanted. Just a nice almost snug fit so it doesn't have any play or anything, and it'll roll inside of our front plate and allow this hexagonal shaft to be round, or actually octagon shaft to be round. And so that's this piece. We'll be back in a few and we'll start working on some of the other front gears that go on this shaft.